Hello everybody, I'm Inouye Assia from the Lesak Laboratory Faculty of Sciences, University Sidi Mohammed bin Abdullah Fez. I will present you our paper entitled Face Detection Based on Deep Learning Approaches, a comparative study, co-authored by the Professor Moulay Abdouahid Sabri and Arab Abdullah and me. Before starting, I would like to thank all the organizing committee of the SACS 23 conference. I will begin with the introduction that I will present you the facial detection classification and present some approaches and techniques proposed in the literature. I will present you the proposed comparative study with the experimentation results and discussion. At the end, I will present you the conclusion and some perspectives. The study aims to conduct a comparative analysis of facial recognition approach based on deep learning, a custom image database adapted to the Moroccan context was collected manually for this purpose. The study encompasses face detection, classification, and facial recognition tasks. One of the fundamental tasks in computer vision is face detection, which plays a vital role in numerous applications ranging from surveillance systems to human-computer interaction, including security, entertainment, healthcare, biometrics, marketing, and more. Face detection refers to the process of automatically locating and localizing human faces within images or video streams. In recent face detection and classification have gained significant advancements in the field of computer vision and the pattern recognition. Numerous approaches and techniques have been proposed to tackle the challenges associated with these tasks. This topic comprises two different and complementary aspects: face detection and classification. Face detection refers to the task of automatically locating and identifying human faces within an image or a video stream. The goal is to identify the presence and location of face in an image, often by drawing bounding boxes around them. Face detection algorithms typically analyze the visual feature of an image to distinguish between face or no-face region. Face classification involve recognition or categorization face based on certain characteristics or attributes. It goes beyond simple face detection and aims to classify faces into predefined categories or classes. These categories can include age, gender, facial expression, or even specific individuals. One of pioneering works in face detection is the Viola-Jones algorithm, introduced by Viola and Jones in 2001. It uses a combination of hard features and cascade classifier to detect face and image. In 2005, Diana Interacts proposed the histogram of oriented gradient hog-based approach for face detection. It computes the distribution of gradient oriented in image and detects faces. Many robust CNN architectures for face detection are proposed. In 2016, Zhang and al. proposed a cascade deep learning architecture for face detection called multitask cascade convolution network (MTCNN). And all introduced in 2016 the single shoot multi-box detection SSD approach for face detection and classification simultaneously. SSD uses a single deep neural network to generate a set of default bounding boxes and predict the presence of faces within each boxes. A multitask deep learning framework for face detection, landmark localization, and gender age estimation called Retina Face is proposed by Deng and al. In 2019. It employs a novel architecture that integrates a single-stage face detection with a multitask function. For face classification task, Tarp and Penland proposed the Eagle faces approach that utilizes principal component analysis (PCA) to represent face and linear combination of eagle faces. Facial faces proposed by Benhumer in 1997 extend the eagle faces method by comparting features linear discriminant analysis (LDA). And deep face introduced by Tigman and all in 2014 is a deep learning model but learned in embedding space for face classification. Deep face uses a deep convolutional neural network to extract facial features and maps them to a compact representation. In 2015, Scharf and al. presented FaceNet, which employs a Sims neural network to learn a robust face embedding space. FaceNet learns to project face images into a high-dimensional feature space where the distance between embedding corresponds to face similarity. As Chang and al. in 2023 proposed a hybrid face classification approach based on FaceNet, Inception V3, and MobileNet V2. The proposed approach used transfer learning to classify faces in case of mask face wearing. The main objective of this work is to conduct a comparative study between the most well-known and commonly used approaches for facial detection and classification. This comparative study will focus on both parts, face detection and classification, to identify the best approach for each of them. In our study, we choose to create a custom dataset in order to personalize our recognition system. For this task, we will use a face image database that contains 12,600 images classified into 7 groups of people. The images include both veiled and unveiled women. The images are color images with a size of 100 to 500 pixels. The most commonly used features for evaluating a classification model are sensitivity, specificity, precision, and accuracy. Accuracy is the number of objects correctly classified compared to the total prediction. Recall or sensitivity measures the number of samples classified correctly in relation to all relevant samples. Precision measures the pertinence of the true classes. For face detection, the comparative study will be conducted to see the efficiency of the 3 face detection approaches: orient gradient walk, multitask cascade convolutional network (MTCNN), and single-shot multi-box detector (SSD). From results presented, we can see clearly that the MTCNN approach is ahead of the 2 others followed by the Hawk method, and the SSD approach is the weakest approach. We can conclude that as accepted and as our literature review has clearly pointed out, that the MTCNN approach is the best of the 3 approaches studied here for face detection. To this end, we will now use the MTCNN algorithm for face detection prior to classification. For face classification, the architecture implemented are AlexNet, ResNet 50, VGG16, MobileNet V2, and FaceNet. The accuracy and the recall are used to evaluate each of the 5 deep learning approaches. We will use the one versus all to calculate the accuracy and the recall metrics. Just to note that We use transfer learning in case of the AlexNet, ResNet 50, and the VG60 and MobileNet architectures, where the initial ones were obtained by training them of the ImageNet database. We can see clearly that the best architecture regarding the accuracy value, but the VGG16 remained the best one and will land on the local measures. In this work, we presented a comparative study to explore the best approach for both face detection and face classification. We first studied three popular deep learning approaches for face detection: HOG, SSD, and MTCNN. Among these methods, MTCNN emerged as the most effective approach for the face detection, providing accurate results. Furthermore, the study evaluated 4 different classification architectures: AlexNet, ResNet 50, and VGG MobileNet V2, and FaceNet. It was found that FaceNet achieved the highest accuracy value, showcasing its potential for the face classification task. As a perspective, we can use all the studied classification approaches in an ensemble-based approach, face detection and classification. And thank you for your attention.